Hey there. In this video, we're going to look at how if you're given a point on the terminal arm of an angle, you can use that to determine the measure of the angle.
All right, in our first example here, we have a point, -5, -7, that is on the terminal arm of an angle in standard position, and we're looking for the angle itself to the nearest degree. And so to start doing that, a good first step is to draw a diagram of the situation. So this point, -5, -7 over here, -5, -7, you can just roughly draw it about like that. And I will put the terminal arm like that. We might as well draw the initial arm here too. And that is our angle in standard position, theta. And we should probably label the point over here, -5, -7. You can draw a little reference triangle in here if you want. And we can even label the sides of that. This is -7, this is -5 up here. And from that, we can write a trig equation. And the ratio that we're going to use is tangent because we have the y-coordinate and the x-coordinate, and y over x is tangent. So what we can write is we can write tangent of our angle theta is equal to -7 over -5. And in fact, since we know that negative divided by negative is positive, we can erase those two negative signs and just write it as 7 over 5 for the tangent ratio. Now, to proceed to try and find the angle, what we're going to find next is the reference angle. So we're going to use the calculator to find this little angle in here, the reference angle. And so we're going to call that theta r. And we're going to use the tan inverse function of 7 over 5. And so let's get our calculator here. And so if we go to the calculator, tan inverse of 7 divided by 5, you put it in that way. If you wanted to, you could work out what 7 divided by 5 is first, but you might as well put it all in one step like this if your calculator has that ability. If you have a fraction key, you could also put it in as a fraction, of course. This has a fraction key right here. And so I can go 7 over 5, and then it'll give me that. 54.46 degrees roughly. If you're getting something completely different than that, you probably want to check to make sure your calculator is in degree mode. Right on here, you look here. I'm in degree mode here. Different calculators are different, but that would be the first thing to check. So we have that the reference angle is roughly 54.46 degrees. So we're going to say theta r is roughly 54.46 degrees. And now to find our angle, we can use that. This is the angle that we just found. That's 54.46 degrees. And to find our angle, which is this, the way we're going to find it is we're going to say it's 180 plus that reference angle. So if we write down here now that theta itself is 180 plus theta reference, or in other words, 180 plus 54.46 degrees. Since that's using my rounded value, I'm going to say approximately equal to there, and that is going to give us roughly 234. You can put as much accuracy as you want. You could put 0.46. If you need it to the nearest degree, which is what it says here, then we're going to round it down. So it's 234 degrees, like that. All right, and that's our angle. Let's do another one. In this situation, we're asked to do the same thing. We have a point to -√12 on the terminal arm, and we're asked to find the measure of theta. This time, though, it's important to notice it says the exact measure of theta without using a calculator. That means that what we can expect is we're going to be able to come up with the reference angle using some other means, like a special triangle. So as a start, let's of course make a diagram here. To -√12, we'll just put it down here somewhere, and then we'll draw the terminal arm, draw the initial arm. Again, that's our angle theta in quadrant 4. We can again label the point here to -√12. And we can draw a reference triangle if we want to. Negative root 12 is that. 2 is up here. And again, for the same reason as before, we have y and x, so we can use tangent, and we can write tangent of theta is negative root 12 over 2. And we're going to try and find the reference angle here for this. For this, we're going to have to do a little bit of work with this radical here. Is going to be helpful. Now, if you've seen how to simplify radicals before, then that shouldn't be too much trouble. Root 12 is the same as root 4 times 3. And root 4 times 3 is root 4 times root 3. And root 4, you know it's 2, so this is 2 root 3. So it's going to be easier to work with if you write this as negative 2 root 3 over 2. And then what you can do is, of course, you can divide the top and the bottom by 2. And so this is actually negative root 3. So in simplest form, negative root 12 over 2 is negative root 3. And so we have that our tangent ratio is negative root 3. We need to think about how we can find our reference angle without using a calculator. Now, hopefully, negative root 3, or more specifically root 3, jumps out as one of those numbers that comes from one of our special triangles, and the one that it comes from is this 1 root 3 2 triangle that has a 60-degree angle up here and a 30-degree angle down there. And what we're looking for is a tangent ratio of root 3, which is actually root 3 over 1, if you want to think about it that way. And that means that that's the opposite side and that's the adjacent side. And that would mean that's opposite. So it's opposite to that 60-degree angle, and that's adjacent. So our angle, our reference angle, is 60 degrees from that triangle there. So what we can write here is that our reference angle is 60 degrees. We can say it's exactly 60 degrees because we know that exact value from that triangle. And to find our actual angle theta, if this angle in here is 60 degrees, then that angle we can get by going one full revolution there, which is 360, and then subtracting that 60. So we can say that our theta itself is going to be 360 minus our reference angle, which is 360 minus 60, which is 300 degrees. That's our angle theta. We can say it's an exact value, exactly equal to there, not approximate equal to, because we used that exact special triangle to come up with our reference angle. All right, so that is finding a standard position angle, theta, given a point on the terminal arm.